Hello, welcome back. It looks like we're live. Give me 1 second. I'm just gonna confirm that we're live and direct, and I'll get going. Get started. Get it started. Mm, 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 mm. All right. It looks like we're live now. Perfect. So yesterday I was working on, I'm gonna show you now. So I was working on the function definition argument parsing, right? So essentially what that means is now we've got this little bit complex stuff. So I'm just gonna take it out to simplify things. And look, so what I was trying to do essentially yesterday was taking all these arguments and being able to parse them into types like the abstract syntax tree. So for example, if I take you to the field type, which I already implemented earlier, you're gonna notice that we can actually have very complex type. This is an example of a very complex type. This is a union of integer or option float or array of option string or integer or null of size 10 or set. Like this is just a hypothetical example. I don't expect you to have it in real life, but as you can see, when we parse this is a very complex type, right? And I implemented the parser up here. You can see all this implementation which I had done earlier. However, yesterday I was trying to basically go through this argument in my macro implementation, go through each of this argument, then we're going to parse the argument name, and of course this colon token, and then the argument type. So before, let me see if I still have the previous implementation. I might still have it somewhere. Okay, so prior to this I just did a very basic mapping. Yeah, so for each of the type you get here, I map it to a native type I have created in my code base. However, this was prior to having complex types being supported by the database engine, sorry, DB itself. So as you can see, for example here, I'm saying check field type, it could be any and stuff. And you can see that I was using an identifier to represent the type. But this doesn't cut it anymore because you could have a type that has like this angle bracket. So you could have like option, integer, and even have a pipe, or you can say string, right? So because of that, we can't really use something as simplistic as this using an identifier. So I was trying to implement something more robust that's gonna handle all those case, right? So for example, this could now be like option string or integer, something much more complex, right? Or like sets of floats of size 69, and you can just keep on going, right? But this with this new implementation, as you can see, it's not complaining. If I mistype something here, it's gonna complain. You see, it's saying invalid type. So it means if I fix that, it actually does work now. Like it doesn't complain anymore because this is a valid type, which is what we were trying to do. So yesterday I was contemplating between two implementations. So basically, implement the parser almost from scratch using like a combinatorial parser with num crate, right? So we're trying to parse that, but we ran into some issues because of the way the field type parsing has been implemented. So basically, you have to just pass the entire token tree that represents a singular type at a time. Then you can use that type on it. So because of that, I didn't implement this on stream. While I was trying to catch sleep this morning, I just had this eureka moment that, oh, why couldn't we just do it this way? right? We don't even have to use the parser that was used for the field type. And this was what actually led to this. So I'm just gonna disable inlaying first. So as you can see, this is what I'm doing now. I'm using this implementation called parse top level comma, right? So essentially what we're doing here is we have a pointer, and that is the depth. What this pointer basically does is to track the angle brackets. So think of this like, let's say you might have an argument. You could have a type called string, right? And you could also have something more complex as option string. Then before you go to the next one, let's say the next field is going to be second argument, second arg, and that's just an integer, right? So let's look at this. What this does essentially is we have this pointer called depth, and what it does is we have this while loop that does keep track of that, and we pick into the next token. So for example, when we find that the next token is open bracket, then we increment the pointer by 1, which means we are still on this specific type. We haven't changed the argument, because anytime it's greater than 1, it means we haven't closed the top level open bracket. So in this case, for example, if we have something like this, it's gonna come, this is not gonna be fulfilled because the first token here is option, right? So this is gonna fail. This is not gonna pass. This is not gonna pass either, because the depth, even though the depth is 0, the token tree, the next on the token tree is not comma, right? So at first I was actually using this forking. So if you think about, if you want to understand forking, if you're used to like GitHub, it's just like that, right? You can have a repository, then you can fork it, you can work on it, and you can advance that other repository to the state of that fork. But we actually don't need this for what we're trying to do. So basically, I'm just parsing the next token as a token tree, and I'm converting that to a string and pushing it to this type string, right? So when in this case, the next on this will then be option, right? So we then append that option to type string. Then we go again. The next here is gonna be open bracket. When we go to open bracket, what's gonna happen? We're gonna increment the depth. We're gonna push the open bracket to type string. Then we're gonna parse. We're gonna parse the open bracket from the input, parse string. Then when we get to the next again, it's gonna be this string, right? It's gonna be this string, right? So it means it's gonna go to the last, and we're gonna push that to this, right? Then we'll get to close bracket again. It's gonna come here. We'll decrement the depth. So this time depth is now gonna revert back to 0. Then we'll push the close bracket to the string, and then we'll parse the close bracket, right? Then when we'll get to this next, it's gonna fulfill this part, because depth now is now 0. Then the next on the token tree, the next on the stream is gonna be a comma, right? Then we break out. We break out because now we've parsed the type for this specific argument, and when we encounter that being 0 and the next token is comma, it means that we are now onto the next argument, right? And then by that time we would have parsed the type as a string into this type string, right? And then what we do is basically we take this type string and we use this field type, which I had implemented earlier using combinatorial parser with num, right? We just take that, and that automatically does the parsing into our type here at compile time, and then we'll return it. So that was how I decide to like solve this eventually. So even though we are mostly using a more granular type, it's nice to have the full parsing right now, and we can do some nice thing in the future. So if we expand this, let's see what we get. This is quite so let's take that up here and let's just put that. So we're gonna do a little bit of cleanup here. First let's remove that. Let's remove that open bracket and open parentheses, remove that open parentheses, delete that, delete onto that, remove that, change that to this vector. What else? Do the same thing here, remove the parentheses, change that to vector. Okay. Complaints about $sign. Okay, yeah, basically we can do something like that. Okay, so you see what it generates now. It generates the arguments as parameters, then it creates the define function passing all the arguments with their name, in this case first argument, and the type, and it's being parsed. So string, then anyway, so we have this now. The next thing I'm trying to achieve is I want this to be able to also return like a function, a macro. So we're gonna be like returning two things. The first is gonna be the statement itself, because when you want to define a function, you need to have that function embedded within the database instance, because these functions are not only functions you can write within your code and run within your code base, but they are actually functions you can even use from within your database instance if you SSH into it, or you're using like a GUI, which is cool, right? So what we're gonna do now is, one second, try to create respective macro. So rather than using a function, we could actually return, instead of, for example, get person, we could just return a function. But because of the way I'm mostly using this within the code base, right, my functions, let's see if I can show you some of them. If you look at this documentation even, you notice that the functions are mostly, the database functions are mostly implemented as macro, even though I usually support both normal Rust function and the macro variation. And I can show you an example. Let's go to run or HTTP. So if we go here, for example, let's see, oh yeah, I'm using macros here. Anyway, let's see, function. Let's actually look at the documentation. So in this case, for sleep, we might have something like sleep fn, which is function. Then we also have the macro. So you see the usage, you can either use the sleep fn, or you can just use the macro version like sleep. So that's why I'm gravitating towards implementing this as a macro, right? Just close that, close this first, close this, close this, close that, close that. So how do we do that? Let's go to the macro definition and let's scroll up a little bit. We have func macro, and you know what we're gonna do? Actually, we're gonna do let's say a very simplistic macro, and I'll just call it some tests. All right, so let's see if that's gonna work first. Gee, that's good. So how about we go back here? I suspect that we might have to restart our IDE, so let's just do that real quick. Or editor. So once we're able to support the macro, I would say we're in a good position. We just need to tweak a few things here and there, and afterwards going to our test tree. And I think apart from like improving the API of the migration tooling, most like 99.9% of this project is done, at least for the alpha release. So we have that done. This weekend I'll try to finish the other ones, and maybe next week I could actually release the alpha version. And before Christmas or January, release V1. I think that's gonna be cool, and I'm excited. So now it's loading. We want to see if it's able to generate the macro rule called some tests, which we have just created. So that's gonna be used this way, basically. Like we should be able to say something like some tests, and it should work. But first, let's let the IDE load fully. Let's see. Let's try to expand. Okay. Yeah. So as you can see, the macro was generated. So let's try to use it here and see if it's gonna work. Let's call it some test. So the macro was generated, right? So now essentially we want to do the same thing for like the function. As you can see, this was generated and it works, which is cool. So we're gonna do the same thing for the function definition. But this time, rather than just hard coding this, let's remove that. Let's remove this and comment that. This is called generated func macro. We actually want to follow the convention of the original one, so it's gonna be function name. This function name right here, so it's gonna be exported. Let's call this exported func name. Essentially we're just gonna do that. This is the convention I'm using for others also. And the second one, we can just call that, if we go down a little bit, that start from here, we can call that macro function name or macro name, whatever. Use that here, and basically it's the same thing as the original, so we don't gotta do nothing about it. Anyway, is that even necessary, doing something like this? So we can do that, and that's the macro function name, which I think we can just leave it as it was. So So what do we want? We're taking a bunch of expressions, because now when you want to create the macro, think about, let's say you want to create something called get user, right? So the macro definition would be something like this. Get user. So the function is gonna, the top level macro is gonna generate a function called get user statement and a macro called get user, right? So let's say get user statement, for the function we have define it's gonna look something like the get user, right? Let's say we've got something like this. When we want to use the macro, you can think of it like a function definition. Essentially, we're thinking how the user is going to call it. So let's say the user says get user, invokes the macro, right? So it's going to be string first. Let's say oh yeah, then and birthday, something like that. This is how the user is going to be using it, which means actually we're just going to be taking a bunch of expressions. So it's going to be ag or param, actually now it's parameter, and it's gonna be an expression, but because we want repetition of it, right, so we are gonna be repetitively invoking that, and because the user could have 0 or more, we're gonna use the asterisk, right? And that's what we're trying to do here, as you can see. So I think here parameter is what we want to have, so we call this param, because so I'll just call this params. Just gonna take a bunch of parameters. There's quite a few things we might have to change. Param, let's call this param, and that's gonna be params, param, where else? So that is that. So let's look at this from the beginning. We have our private bindings, we have the private args, probably can call that private params also, but I'll leave that for now. So we have these buildings and bindings and buildings clone. I might want to rename that, but let's see what that is. Essentially what that does is it takes all the arguments, and then from there we get the names and the types, and we take the, so let's say for example you have first name first name is string, score is integer, or let's say float, right? So what this is gonna do is this is gonna be something like let's first name, then the type. So the type would actually be the converted type. In this case it's gonna be field type. Field type equals first name. Yep. I need to confirm this because I think this actually, yeah, and the second one would be, let's say, score, and oh yeah, I see. Normally we should take the parameter, not the argument here, so we need to check that. Let's see. Where else are we using this? You know what? I'm just gonna take that off for now. I'll just copy this down so we're sure what we need to use here. So where are we using that? So let's see. Basically what I'm trying to achieve here is we've got these private bindings, and let's see the original implementation. Yep. So as you can see, yeah, what we're trying to do is take the parameter and just convert it into the type. So you can think of, if we have like first name, string, so it's gonna be field type basically, but this time it's gonna be the mapped type, so it's gonna be something like I believe strand like, and let's say you put the first name as code breeder, then it's gonna be something like this. So this is what we're trying to get at, and so we're gonna need the params. Okay, we actually may not need these bindings and clones anymore, because what we're doing here is we are expanding all the parameters here. So basically we're taking all the parameters as list and we're iterating over them. So when we iterate over them, we get the, of course, the index, and we also get the parameter, and then from this index we go to this mapped field type. I think that's all we even need now. So what does that do? Let's remove this part first. I'm too close to the camera. But anyway, so what does that do? Basically it goes over all the arguments, right? Then it gets the type of the arguments and passes that to a token string, right? So in this case, we have this. It converts them to the code base type, which I have here. So what do these types actually do? So the difference between this type and having just like bool or date time or strand or number is that when you have like duration or number, for this kind of type you can also convert fields and statements and parameters. So the nice thing about this is if you're writing a query and you have a statement or a parameter or a field and you want to pass it in place of that primitive, let's say integer, you can also pass a parameter. Rather than passing like 33, you can pass a parameter, or rather than passing like 42, you can also pass like a field, or you can pass a statement. I'm going to show you a lot of examples, and this actually unlocks a lot of capabilities. So what we're doing here, if you notice, is that we're getting those types, right, and we're taking them as a token stream, then we collect them, right? So the beauty of this is when we're iterating over this, we have the index of the parameters, because every stuff here. So let me give you an example. If we create a function called and we say define function called this, right? when we want to actually use this macro, let's say get user, everything should correspond with this, right? So all these arguments should also correspond to all the parameters that we've got here, like everything here. So we've got 3 parameters here, and up here we've got 3 arguments. So this first argument should correspond with this first, and so on and so forth, right? And that's why right here on this line, we create that mapping that basically takes that type and maps it to this code base type. And each of those index should correspond to the parameter index. So when we pass this index, it gives us the type, right? And then we can take that parameter. So in this case, this could now be something like let's say the parameter in this case is let's say first arg, right? Then the type here could be something like, let's say duration like, and it takes the parameter, and in this case the parameter could be actually, let's use strand like is like string like. You can think of it like string like, right? And in this case it could be, let's say hello.into, right? That's what we're trying to achieve here. So it should actually be this. And tell you what, actually right here I think we might wanna use the argument name here. We might want to do that, right? So how can we make that happen? Well, as you can see here, we are doing the map type here, but we can also pass the name. So we just have to decide how we want to undo that. So we can say mapped field name. So let's just copy this. Of course, we can create like a tuple within that. So we can say field arg name. And yeah, rather than this, we just param.name. And I think this should better be argument. So arg, and that also, let's disable inlay int declutter, so that's better called arg. And yeah, we just want the name, the argument name. So that's an identifier already, and I think it's safe to just return an identifier. So we could just basically do this, and I believe we're good to go. We don't need a reference there. Oh, we do. Anyway, so we have an identifier there. So one more thing we can do is in this mapped fit type, we can do, let's copy it. So rather than using param, we can just call this map field arg name, argument name. So that's gonna give us the, it's gonna give us the argument name. Let's use that there. Then we get a type. And in fact, rather than creating this separately, we could just do this here. So we don't have, we minimize collision, and this probably is gonna be this. Vector token string. Okay. So that's parameter name. Um, that's interesting. Because yeah, we're doing something similar, right? Where do we have that? Check field types. We pass on the type. String this true. So I want to get a parameter name because ideally that's what we would like to use here. Of course, it actually doesn't matter if you really think about it, because yeah, it doesn't really matter. Even if we do something like, so obviously we don't want to do this because I think the parameter could be an integer. So even if we do something like this, because that's done at every iteration, I think it should actually be okay. But we check that soon. We'll know that. So remove that. Pass a type. Then extend that, and yeah, we get the function name and now the argument, blah blah blah. We pass the builds. We also pass all the bindings, and for the binding, I really don't see us needing the binding here, but let's leave it first. So let's check. Param is still repeating. Okay. Param is still repeating. Oh, yeah, we. Oh no, actually, I'm trying to take from here. Let's call this parameter C, just to be sure. Because we're not trying to reference parameter from here, but rather we're trying to reference from here. But anyway, so let's see. We might have to restart our editor again. Yeah, we need to. So what that gets us. Field type not found in the scope. Where are we using that? Still loading. It says field type not found. I need to remove that also. I never knew what love could do to us. And I met you. Let's see. But my heart, yeah. You know what? We should actually temporarily remove this so we can focus on the second one. Yes, forever. For the rest of my life, you're one of one. I never let go. Yeah, that shouldn't be there. Without you, I belong. Without you, oh yes, we can remove that. Without you, I believe. I need you by my side for the rest of my life. Knees buried. When I found you, you were the mark. He's working the somebody please. Is this the dream? Oh, nothing compared. Will it just be reality? So maybe let's restart it now. Let's restart again. Let's close and reopen. Somebody please. Second. To try my. Is this the dream? Nothing compares to you. Yep. still loading. Nice. Map field type not found in the scope. Oh yeah, we are not referencing that, and we don't need that actually, so let's quickly restart. So now it's complaining about that map field types. Yeah, of course, because this is that's not gonna work. That's like token vector or vector. So well, we can do yeah, that's not gonna work that way. What we would have to do is this was disabling length, take that, then map field types, we take that, we cannot index that just like that. I mean, we can do something archy, like we can say mapped, yeah, then that would be we can do something like this. Let's restart, but we have to find a better way, maybe. Yep, so yeah, let's see what we have now. It looks like we're making some good progress. It's still loading. Perfect, so let's copy that and let's put it down here. So we got like get person, and as you can see we get vector. Oh yeah, I've been forgetting these are actually types, so we can do that as the first thing. Then this should be just type, Oh no, map. Okay, yeah, this is where the problem lies. In map field types, we need to be doing this at compile time, because these are all types. These are all types, so we couldn't do what we're trying to do, which is a bummer. So my field type. But we're gonna need the parameters. So is there a way we can maybe create a function? So we create a function that takes the parameters. So let's say yeah, it takes the parameters, right? Then at compile time we can, cause the parameters, we can get the parameter at compile time here, right? At least we can pass it to the function. Because what we really want to do, because these are done at compile time, what we really want to do is basically, let's come here. We want to take this and do something like, let's say this. We do so param, and we can do private binding. And then we want to take basically each of those parameters, but this is gonna be interesting, because let's say we create a closure and call that xx, and we just take params. We just got it. No. What can we do there? What can we do? Let's sit back and think about this a little bit. So we're looking for a way to map the index to this on um I might have an idea. I might have an idea. Oh. So we're just looking for a way to match up these parameters against the arguments, right? At least the position, the index. So this to that, so that when we have these parameters, we want to get so normally what we could have done would have been something like this. Yep, something like that. And maybe we can do that. Map field type Agne. Basically something like this. So in this case, let's say this is first name code reader. We don't even need to do that. We can just do param. But so basically we're trying to find a way to repeat this within this also. Let's restart. Yeah, param into my field types. I know the right way to reference this should be this, but let's leave it at this first and see what we can do. So those are basically just types. They find a way to bring it into the scope. I'm getting an idea, but see, yeah, I knew that was gonna complain there, but just wanted to see how they intermix. Yeah, I was expecting this to complain. And why doesn't that repetition? Okay, yeah, it's still the macro definition. Yeah, no, this is meant to be this, but then it's gonna complain. Or doesn't it? Yeah, so I need to figure out basically how to mapped field types. Of course, I know you want to deal with that, but this is not what we're trying to do, right? We're not trying to expand the field type then equal to, no, that's not what we're trying to do. That's a good strategy we can use here, because those are types. And so let's say we have string int float. We want to expand that. We're not trying to do something like Is there a way to intersperse macro? If we can intersperse them, that would be cool. At compile time, I'm sure we can, but is there a way to do it without implementing some complex procedural macro like custom? So what I mean by that is, so these are the types, and these are the types from the parameters, right? I mean from the argument. Then we also have like the argument. So first name, something like that. So is there a way to intersperse this to say something like basically do something like let param string equals, yeah, this is what we're trying to achieve. We want to map this to this. Yep. But the problem is outside of this, we don't have the parameter context. So one idea, so that's what I'm looking at here, that we could take all the arguments. Those are types. So maybe we could create a macro that Could we do something like this? Like make a macro within this. I call it, let's say, macro. Oh, maybe not within there. Okay, make a macro. I just call it test, and then this this takes that. So you take that, and I'm having a block, mental block, but I really want to get this done before I go out. Let's try that. And I'm actually wondering if something like this could work. Something like this could work. But you never know until you try. So that's exactly. You never know until you try. Still loading. Let's wait a little bit. Still loading. Give it some time. Let's give it some time. Let it snow. Let it snow. Yeah, still loading. Okay. Param is still repeating. Yeah. That's the problem. So could we yeah. I'm not sure we could. Let's see. Attempted to replace the container. Yep. So, what strategy can I use with this? I'm gonna take like 5 minutes to think without trying to implement anything. I think that could help me. So I'm gonna take 5 minutes to think about this now. So first, I'm still here. I'm just trying to think this through. If you're just joining, I'm still solving this. I'm just taking a few minutes to think through the problem I'm trying to solve rather than trying to like latch on the keyboard and trying to, solve it right off the bat. I'm taking time to think through the problem and a good way to solve it. So the problem we have now is we're able to get the types we're trying to map right here. So in this case, the type could be, think about integer, or it could be float, it could be duration. But we're getting list of those types from outside these macro rules. However, we're getting the parameters from within the macro rules. So what I'm trying to do is, so we have something like a list of the types. Yeah, this is an example. It's not exactly the same. While we have the list of the parameters here, and what I'm trying to solve now is the ability to intersperse that. Like, so we have, and don't forget this is like a macro stuff, so it's gonna be done at compile time. So we really can't use vector here because it's a type, or these are types. So what we want is just a way to, while repeating this, we want to intersperse this within this. So string and first name, integer and 32, float and 32.0. So that's what I'm trying to think through, and so um, uh, so I actually have an idea coming to my mind now. It's crazy. I have an idea. Um, and it's gonna be interesting. So let me show you what the idea is. Um, um, so how about we? I'm actually not sure if, how about if we try to do something like this. Um, First, before I try to do that, let's see if it's even gonna work here. It would take this and we just put something here. Let's call this let's do something like that. Map type. Yeah, so let's see if that works. So I just want to see this. Then we're just gonna move it as part of the macro argument and use it there. that load already. Attempting to repeat an expression. Okay, if that does work, then we might be up to something. So as you can see, we are getting repetition of this. So we might actually be up to something. Okay, interesting. So what if we can get a vector of parameter and just because we can get a list of the parameters. So then we have the list. Actually, I have an idea. I have an idea. It's gonna be crazy. Yeah. I have an idea. I have an idea. So I've not tested this idea, but I think it can work. So since we've collected it into a vector, essentially what we can do is so we're repeating this, right? We can do this, and what we can do is take that, right? So we have params, right? Then yes, next, right? And of course we have to unwrap it. Let's say params does not exist, right? And essentially every time we are mapping this, right, we are just taking the parameters here anyway, and then we are, yeah, even though this looks crazy, I think it's gonna work. So let's restart. Yeah, this was why I wanted to take a break, so the brain can think a little. This is gonna work. Of course it will. It will. Oh, we might, let's see, if we have a vector, I just need to confirm something, because we might actually have to turn that into an iterator. But let's see. Let us see. It's still loading. Once it's done loading, we're good to go. Okay, looks like that loaded. Well, contain those, anyway. Yep, I think yep, this is more like what we want. So yeah, what we can also do is move each of these so that we can bind this. Nice. So what I'm gonna do is this um, let's do it that way. So we can remove this safely. Let's restart. Yeah, we're waiting for that to load, but it's looking very promising. I'm excited. Nice. Nice. Yeah, once we're able to conquer these, we'll do a little bit of tweaking here and there, add a couple tests, and we're done. I need to be out in 3 hours, and before that I need to prepare for about an hour to trim a little bit. So say in 2 hours I I need to time box myself. So in 2 hours time I would like to start getting ready. But I think this should solve the problem we're having. Yeah, next not found. That's understandable. So this has to be it or into yeah. Let's restart. That was what I was gonna do. So we need to turn that into iterator, and then we can do whatever we want to do after that. So once I'm done with this, I need to confirm a few things. Once I confirm that, then we're just gonna make a couple of like snapshot tests for all these queries, define functions, define function, query turbo, transaction, and block. So once we're able to do those, I think I'm gonna open a PR, clean things up a little bit, then open a PR, and we're good to go. Let's just wait for this to load. I know there's been a lot of pauses in this video, but it's for the best. Sometimes you need to take a step back and rethink your logic, and when you're so caught up trying to like just type and like implement something, then you're not able to see things with with like a fresh perspective. And that's why sometimes you might have experienced this, that you're working on something and you just talk and you just go for a walk and come back and like voila, you're just like implementing it the right way. That's because you've taken a step back, walked away, gotten like fresh air, and you're able to think from a fresh perspective rather than being fixated on the path you've been on, you know. Because as humans, I think there is this thing about sunk cost fallacy. When you've gone through a path for very long, it's very difficult for you to retrace that path, even if you have like a if you have like an inkling or like a feeling that this is not the optimal path anymore. I need to maybe tread another path that might be better. But because you've gone past this path, a very long path, it's very difficult to trick your brain into uh, throwing the other path. So you just have to be intentional about, okay, this path is more optimal. I've gone this path for a very long time, but it's not working for me anymore, or it's not the optimal path. Maybe I should retrace and start from a fresh perspective. And that's what happens when you're trying to code sometimes subconsciously. Um, so essentially, what just happened here is, imagine if you have like a vector. Let's call this 1, 2, 3. Right? You cannot do next on that because it's not an iterator. You have to turn it into an iterator first. It's a collection, not an iterator. Then now you can say next, right? You can say next. I've actually not used this next back. Interesting. I can see that being useful. So let's go back to where we were. 19. Move down to this point. Then let's see what we got now. Okay, it's looking promising. So now this gives us, we get the bindings, we get the parameters, because this will still be expanded, right? And this gives us this. So we get the first parameter. It's looking promising. We get the first one, we bind it, we build it. We get the next one, we do the same. And once we're done, we don't need this last colon. When we're done, we have the private args and then so actually we need to fix that function name. Where is it? So this should be, because we're getting that from outside. And we may not even need this stringification, but I'm gonna leave that for now. So we build that and we build the function. Where's the unnecessary colon up there? Where does that come from? because we're getting extra colon here, and I wonder where that is coming from. I'm not sure. Anyway, so we get that, and we get we build the function. So let's try to. We already have this get person macro. Let's just comment that one out. So let's assume we're using something called get person, right? And we do something like that. Never mind that. Let's try to expand this now and see what we got. Where we place it here. Let's call that XX. Let's just call this vec. So you see, now we have the parameters and we just keep on getting them. This should always like work because we are doing it at compile time, and then we get all the bindings, then we do the formatting and all. So that actually looks good to me. I don't see anything really missing. As you can see, for the function name, this should now work. We're not using this anymore, we're using the right way, which is this. So that should work. And I believe we don't need to stringify. Maybe I don't think I'm wrong there. We don't need that anymore. Yeah, then remove that, get that. So we have this, and I think we're actually good. So what this is what I'm gonna do. Just remove that also, and oh, am I checking the wrong place? Oh yeah, I am. Anyway, so yeah, I was checking the wrong place. That's why we have that. That should be enough, and we don't even need that anymore because we're doing this here. Yep, let's remove all this part also, clean that up, and we have to decide if we also want to implement the function variation of it, but I'm not sure we need that actually. But if we want to, it's gonna be something like this. Function name, let's put a function name. What else? So rather than using these, actually maybe this is a little bit better, because, and why is that? Here we're able to actually get a type. So let's take this off. Name and type. Yeah, we're able to do this because the name of the function, we also get a type, and then we can just extend those. So unlike the macro side of things, since the function params, as you can see, since we're gonna be doing something like this, into type name. So when you first get that, you want to take the name, and actually this should be this, and this. So you actually want to name, okay, this also. So you take the name and you parse it. Yep. Anyway, I was using mapped field types. Here we are. That up. Name. We don't need this. So let's comment this out, and actually let's commit this. Let's call it implement define function statement macro generated macro function. Now, if that's descriptive. Yep. So let's see if this loaded already. So it seems like we're still getting some extra semicolon somewhere, which we might have to figure out. Okay, that's doing what it's supposed to do. It's looking promising. Let's see what it actually returns. It returns a function. Great. So are we also able to get person statement? It looks like it, but it's returning on unknown, and so it's saying expected value from macro. Anyway, so we need to figure that out. Expected value from macro get person. Tell them why are we getting the macro alone? And didn't I restart this just now? I thought I did. And anyway, this also should be this. We don't need to stringify. So what's missing here? Da 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 da. Da 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 dum, da 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 dum, da 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 do da da dum. Oh yeah, I see where the extra stuff is coming. Take that away, take that away. My computer is slowing down. This is the maxed out M1. What's happening? I need to check my activity monitor. So I'm gonna start again just to be sure. And what can I close? Definitely this is consuming some power. While this is loading, let me see if there is something I can close in the meantime. Maybe it's time for me to switch to the M3 MacBook, right? We'll see about that. We'll see about it. Okay, it's loading. We'll be done soon. Okay, so let's see what we've got. We're still getting an error here. Let's remove that first. It's not a right. Then we press the arguments and the body. So how does that complain? Cannot find value, good person. So we have the macro generated, looks good. The function also generated. As you can see, this worked here because of our functions, like is, as you can see here, our functions are defined. So just I'll expand this. Oh, okay. We need to stringify that for real. I see where that problem is coming from. Stringify. Where else? Oh, I need to close this because this is not where I should be doing it. I should be doing that here. So Yep, that should fix that. What else do we need to fix here? I think we are pretty good. What I'm just going to do now is restart my editor so that we're sure that everything works as it should. And with this now, we're going to be generating three things actually. We're going to be generating the statements, the function, and the macro. Can I borrow params as mutable? Let's see where that is happening. Oh yes, yeah, because this consumes next consumes that, so that might be problematic. So let's go again. So with these changes, let's just commit. Let's just fix that up. With these changes, I think we are good to go. Basically, we're going to be spitting out three things for each. So let's say when we define a get person function, we're going to get a get person statement, we get a get person macro, and we also get person function, like following the convention that we use for other native SerialDB functions, which is cool in my opinion. Let's wait for this to load. It's already complaining about type is private in function arguments. Define function. I'm still contemplating whether I should use should just use tuple here, but represent function define define function statement argument. So this will be the name of the argument, and this will be the public argument. So let's come here. As you can see, we're getting this, and this returns a function. Then we should also get person. We can. So you prefer to use. Let's just copy this. Like if you prefer to use the function variation, this way we are able to, as you can see, this also returns function. And lastly, we get the statements, which you can find below here. And it does seem to all compile, except, let's see, where is this coming from? Okay. We need to delete this because now we are implementing that as a procedural macro and not a macro rule, and that looks good actually. I might do a little bit of refactoring here and there, but overall I'm pretty happy with what we've got now. So created that this could be, let's say we use date time, and let's see what that gives us now. Bound. Let's see why from string to date time. Where are we trying to do that? Why we do int? Interesting. So let's figure out where that is coming from. Before that, I think we should commit our change. Let's just fix that up. Yep. So what we would change is to a date time. Let's see what happens there. The reason that doesn't work is because before I conclude, I might want to confirm created at is spaceship. Let's just go model. We're trying to press that as field type and so where we getting that I don't think from here. Doesn't look like it. Okay, it doesn't look like from there. Okay, let's see. Yeah, I see. Because I see why that is yeah, I see why that is happening. And it's the correct behavior. That's so cool. That is so cool. So we take that off. Let's comment that out. So the reason why we're having this, which is the correct behavior, as you can see, it's here because datetime cannot be string cannot be converted directly into datetime. So you would want to use a proper datetime stuff here, right? So I don't know, whatever you want to use, or like you could also use a parameter here. A parameter is gonna work. So you do param or param new birthday This is gonna work. At least it should. It should, cause that definitely should work. Because it should also allow parameter statement parameter less statement and also field in that context. So, and it's not. Let's see why that might be the case. If we revert what we just add here. Just try to do it again. Let's do param sky birthday. So where's the complaining here? I see. If I'm using vector here for the parameters, then it's gonna wanna expect the same thing. Like a vector has to be single type, so that's reasonable. But can we box that? Yeah, so they all have to be of the same type, even like if I'm gonna pass that in. So this is gonna be a problem. Personally, I've got this array type that I think might solve this problem. What if we try they don't have everything to be. So I'm thinking of mapping them into their respective type, then to value like type, and this is a good question. I mean, I could box them. So, what do I mean by that? Say, let's try something like this. Say we've got P1 equals this. Then we've got P2 and P3. So we can, of course, superams equals. So we can't do something like this because they are of different types, right? So it's not possible for you to put different types within the same vector. For you to do that, you would have to box it, right? So what do I mean by that? You would have to do box then so this is what I mean, and this would be of type what traits could it be? I'm not sure if this would cut it. Could we even do something like that? Can I reuse that trait object? I don't wanna. So this makes it a little bit tricky. Because I mean, we can find a way around this using box, definitely, but I don't want to defeat the purpose. Because if we first convert into, let's say, value like, then it defeats the purpose. If I want to, if you're supposed to have like a date time, then I first convert it to value like. Obviously, that conversion is lossy because we're converting to a specific type to a more generic type, then back to a specific type. But now we've lost that we've lost that specific type checking, and we wouldn't be able to say, oh, okay, this date time should actually not be string. It should be a concrete type date time, or it should be a parameter or a field, right? And that's why I'm trying to avoid um, using dynamic dispatch here. So let me see. What would be a better way to approach this? This is a little bit tricky. Um, I don't wanna. I don't wanna use dynamic dispatch there. I don't want to. Um, hmm. But actually, another thing we could do, which might save us all the stress, is since we have the function definition here, we can just call the function, but I don't want to embed the function into every macro invocation. But that's something we can definitely do. We'll take the function definition and we just invoke it and just pass the arguments, and it's going to take care of everything. So that is I'm just gonna copy this. You know what, yeah, I'm just gonna copy that. Let's say to line 30. Let's paste that. So basically we can decide we wanna put the function definition right within it, within the macro definition, or we can make it a standalone function which we can access from the path. But the problem with that is it's going to be defined within the user code, and there would be no way to deterministically access the, at least not that I can think of right now. So the only way would be for us, and actually, you know what's crazy here? We are already defining the function within this scope, right? We're already defining the function, and since we're doing that, it means anywhere the function is, anywhere we define this macro, the function should be available within that scope. But the problem is, because the way macro works is actually at compile time. So when a user invokes, let's say get user, wherever the user invokes it, right, the function may not be present within that, might not be present within that caller scope. So this is what I mean. Even though, for example, here we have the get person function, we can just use this right inside of this place, and that will solve all our problem. In fact, we don't have to re-implement all these things. We don't have to go through all this bullshit. We can just invoke the function. But the problem is when you're invoking this macro, right, it's doing that at compile time, and if this function get user fn is not present where you're calling it, so if you're calling it from another file, right, it's actually not going to work. So you would have to specify the full path of that function. What do I mean by that? Like if you come here, let's say you come here, you would have to say something like path to function name. You would have to do something like this. But because this will be defined within the user code, there's really no way you would be able to tell that deterministically. So the only way I can see forward is that you are going to take the function definition, embed it within this macro, right? And then you're going to call the function with this exported function name, and do something like this, and this will actually solve our problem. This will solve our problem, right? This solves all our problem actually. So let's restart it, and the function is not so large, so it shouldn't be a problem, I think. Actually, I might have made a mistake there. I'm thinking this should actually be defined outside of here, but we'll see. Yes. Still loading. Yeah, looks like it's downloading. So this is actually gonna solve all our problems. I don't know why I didn't think of that before, since we now have the function definition implementation. Pop okay, let's see the macro. We're actually interested in this now. So we have this function, right, embedded within the macro. And we can also define this as as a closure. Yeah, so that looks good. Define the function. But the problem with this now is we're gonna be having this everywhere we call that macro, we invoke that macro. So we just have to could you do something like this? So I'm actually curious about is this. If you want to guarantee that function is always going to be present, right? We need to define it inline. That's the only way we can guarantee. And I want to see if we can actually use closure. Yes. This is the way we define that. Equals, change that to this. Okay, so we might not be able to do that here. I mean, with anyway, this is just for like making our lives easier, but I think I still prefer that. So this should work, right? Okay, let's remove that and let's restart. So this should go within this. Yep. So let's restart and let's make sure everything. Yeah, it's looking promising, right? Yep, it's downloading. Let's see. Moment of truth. Now this works and it's able to take parameter here. But what you're going to notice is if we try to pass, let's say, an integer, it's not going to work because it's expecting a date time. See, it's really cool. If we pass just a mere string, it's not going to work because now this is expecting a date time. You know what? I'm gonna take this all out. So what if we put let's say duration, right? Now this is expecting type of duration, so it's not gonna work. If you put string, doesn't work because it's not convertible to duration. And if you put just 45, it's not duration, right? But if you do duration from second, now this works. You know what else works? Let's do param. You know what else works? Let's do field. No, yeah, this also works. That's the beauty of it. That is the beauty of it. But for now, for birthday, created at probably should be date time. Let's see something spaceship. Let's see something a little bit diverse. As you can see, that's date time, right? So it's expecting a date time, and here we can pass gonna, I don't know, let's give me some kind of date time. Yeah, as you can see, these three all work, but this wouldn't work if you try to put, let's say you try to put integer. It's not gonna work. You know what else is not gonna work? If you try to put some string, it's not gonna work because it's expecting a date time. So it's very strict. These two are not gonna work, but this other three would work. And same goes for this. If you're writing it as function, so you can pretty much do this. So that's it. Nice. So we did this. I totally forgot. This is the way I've been implementing it actually. Since we've already implemented a function, we don't even need that. So we're sort of good to go. Yep. I think we're good. We're good. This solves our problem or problems nicely, and it's actually cool. So I'm gonna commit. I'm just gonna fix it up. Yep. So I've got about 30 something minutes. I'm pretty happy with that. So we get the function, we get the statement, and then we also get a statement. So we're gonna return so from if it's gonna be a little bit different. So why we do something like this? I want to do a little bit of cleanup here. Let's clean this up. Let's remove that. I'm glad we kept that function. Yeah, we'll keep this just to confirm that later. So this would be the statement. Yeah, I don't think we need to do any crazy abstraction. We can just leave that. Oh, I could have just actually made that a separate commit, but it's okay. So we probably want to have some tests. Oh, first, let's see if close others. Let's just define function statement. For the body, we need to pass a block to it. But I'll actually say, since I don't think the body has to return anything, we probably want to take query chain, and let's go to the definition of block first. We're going to remove all this that has been deprecated. I was using macro rules to define all this before, but as you can see, it was already getting complex, so I had to change it. So query chain can be converted into block. So you know what? It's probably just sufficient to do the implement into block, since query chain can also be and then we say body. Yep. So in that case, this would fly. So we just need to write a bunch of tests now and clean the code up. I think that should be fine. Otherwise, yeah. So if you pass in block, then block is block. If you pass in query chain, then it's just again a block. You might keep my trust too. You're the sunshine to my day. Yeah. Let me be the one you run through the darkness. I'll be your light. So would you be my angel? I will be your man. Together we can make it. If you take my hand. Allow passing query chain to define function statement. So what we're gonna do is rather than returning the entire if else statement, I think it's better to have it that way. Of course, if you want, nothing stops you from doing this either, since if is an expression itself, you can totally do this. I'm gonna leave that actually. So let's do a little bit of testing. Let's check. So this is query define function. Pretty much your function can take anything. Query turbo can take with for loop, if else statement, and so what we're gonna do is we will have like different define function with if else and for loop. So we could have something like this and just use we'll maybe first test this, and after testing this, let's see query turbo also. Yeah, we need to update all these tests. And yeah, I think I'll probably prefer having a snapshot here. Otherwise, it's gonna be a little bit cumbersome. So I have to do this manually. So let's take that off first. So yeah, let's test. Okay. Let's go to this. because I have a lot of tests and I don't want to have to run everything from scratch. So I'm just writing tests for it. I think we're actually in a good spot now. We just need to update the test, and after that, I think this PR should be ready for merging. It's been open for a while, but I was sick for a while, so I'm still a little bit sick. But I think we're on a good track. So I'm quite excited for that reason. This might take some time because I've not run it in a while. My computer is roaring. So as you can see on line 86 here, line 86, that's expect something different now. So since we're actually gravitating towards using the macro, we might want to do something like this. If I use chrono UTC now, then it's gonna change every time, not deterministic. let's just let me see if that changes 35. Yeah, again, that's parameter. That makes sense. Yeah, we don't have to bind parameter until we can. Yeah, this is field, name field. And we'll go to the macro name field on 984. Okay. We probably should be running just this file actually. Yeah, the name date time. That's the raw. Yeah, parameterize. Yeah, per field and param makes sense. Then param field, raw param field. Oh yeah, that makes sense because it's just the raw binding. Yeah, raw param field, nice. Yeah, I think so. Oh yeah, I'm actually writing this out. Let's just put one minor stuff here. Yeah. Okay. Sure. Interesting. So let's see if the function corresponds to what we've got here. Define function get person. We have the first arg of type string and that of date time. And then it is person select all from spaceship where ID is equal to first arg. Yeah, I need to probably make that ref. Yeah, I need to do that. But anyway, and name equals last arg created equals to birthday. Then if person is not null, the ID, and actually we can simplify this here. We can write this as if person, the first person is ID is not null, return person, otherwise return creation of the statement. something else I think I would want to change here in this is say update define statement function test. So what I would actually like to do is remove that. What's the full part of this? Standard converter into convert. Okay, I know I always write converter. Define function. Yeah, I'm just gonna make this a reference, or I mean I could also do this, but do that so that way we don't have to do all that. That should change. Okay, the macro changes, but not the generated code. So I've got about 15 minutes more before I need to start going to prepare. After that, I'm gonna take about 10 minutes rest and start preparing to go out. But this is already looking promising and I'm excited. I'm gonna write some unit tests for this. Just so define function, line 1, okay, so parameterized. That's good. Let's see. Then we have to write an update test for query turbo, transaction, and block. That should be easy peasy. Query if else. Query if else. So we're done with that test. We'll add more tests to that actually. Yeah, we're not using then anymore. So we go to line 71. This shouldn't have. Yeah. Honestly, I think at this point it's just better to use top level query turbo to write a for loop. It's just so much better. It's so much better. I mean, I could convert all this into query chain. So for example, this same test can be written as let's leave this first. You can do like let's put query results. Just query turbo. I just do if like that. Yeah, I think this is probably a good place to take a break. I'm pretty glad with what we've achieved today. We've been able to implement the parser for the define function statement argument, macro argument, and that seems to work well. And also now we're able to generate the statement and the so for example, let's say you want to implement a function, a database function called get user, right? You can define that function, I mean the implementation of that function itself, run it against the database, right? Then you can also call that function, right? So anytime you need to call get user, you can call that function. And because of the convention we've been using within the code base, so SolidDB has a bunch of functions that you can use to do different stuff like array function, HTTP function, geo functions, crypto functions, and all that. The way I've implemented them is that I, for a specific function, let's say rand function, right? I create two variations, the normal function variation and the macro variation. So the macro would be something like rand exclamation. Then the function variation would be rand underscore fn, right? So if you prefer to write normal function or macro, and the reason why I gravitated towards using macro is that it's more flexible. So sometimes there are some functions that have like optional arguments, and while you could use the normal function and use like option, none, sum, and stuff, macro gives you the flexibility to just put two arguments or one or four or more, right? And that's why I'm supporting both. At least that's one of the reasons. So in order to follow that convention, within this custom define function statement, I also allow those two variations called the function name underscore fn and the function name exclamation. That's the macro variation of that. So you get three things when you implement this define function macro. First, you get the statement itself, which you need to run against the database. Second, you get the function fn variation and you get the macro variation, those three things. So when you run the statement against your database, you don't even have to call the function from within your code base. You can SSH into the database instance, or you can also use your GUI or any other ways to communicate with the database, and you can still call that function as raw statement and it's still gonna work. So we are updating the tests. I did notice something. It seems like when we're returning, at least for this select statement, it's not being properly bound, because I should be able to, when I say to raw, it should be able to give me the raw statement. So that's something we need to look into subsequently. But because I need to leave, I need to go out soon, I would have to trim, get ready, and relax. I have to take a break now, and if I can continue tonight, I'm gonna continue. But it's Friday, I should have a little bit of fun. Otherwise, tomorrow I'll be back. I love you guys. Keep learning, keep coding, keep having fun. Don't take life too seriously. And peace in the world at large. I love you guys. Thanks for joining. I appreciate you. And if you're new here, please subscribe. I will be bringing out a lot more content now. As you can see, the last time I actually put out content was like 4 years ago. Life happened, and I'm glad that phase is past. I'm back now. I'm working on a few open source projects just to support and give back to the community. I'm excited. These are large projects. And after these, there's Trust. There is also class name. Those three projects. Other than those three, I'm also doing something like CDK test. Right? I'll implement that. And after that's the fourth. I'm implementing some TypeScript macro like function. That's the fifth. Then also there is one, yeah, some OAuth like passport kind of, if you've used like um passport JS and things like that, you're gonna understand. So basically, for doing your OAuth2 authentication and things like that, I've done some of those probably most of those implementation personally in some internal projects that I have, and I'm planning to open source that. So I have about 6 projects that I'm open sourcing, and I'm also working on a book basically for this project that I'm working on. Sorry, ORM. I just need to update a few things. That's the 7th project. I have another book on macro, you know, and I also have a course on macro and also this thing that I'm working on. So that's about 10 projects. So there's a lot. I'll be bringing in more content, not just about Rust. I've worked with 9 other programming languages professionally. So I think Rust is probably my ninth or 10th, if I'm not mistaken. So there's a lot I think I can teach. And yeah, I'm actually doing the work. So I'm not just teaching, but I'd like to think I know what I'm doing. So it'd be nice to share all those things with you guys. I love you. Again, I'll continue with these when I can. I need to take a little bit of rest, get ready and go out. See you guys and have a wonderful weekend. I'll see you again maybe tonight or tomorrow. Peace.